Next we have to consider the expansion of this macro invocation, that is wrbuff 05 comma buffer comma length. How this macro will be expanded. So this is another invocation. Okay, so this is the corresponding macro definition. This definition will be there here. We already said at the starting of this program the definition will be present. ഇവിടെ നമ്മൾ എന്താണ് രണ്ടിൻ്റെ ഡെഫിനിഷൻ ഉണ്ട് നമ്മൾ നേരത്തെ പറഞ്ഞായിരുന്നു, WR ബഫ് ഡെഫിനിഷൻ. അപ്പോൾ ഇത് ഇവിടെ ഉണ്ട്, ഈ ഡെഫിനിഷൻ ഇവിടെ ഉണ്ട്, അത് നമ്മളിവിടെ ഒന്ന് ഡീറ്റെയിൽഡ് ആയിട്ട് ഇവിടെ കൊടുത്തു എന്നേ ഉള്ളൂ. ഓക്കെ, so whenever there is a invocation to this macro, the corresponding arguments will be replaced. Buffer to second one, this is based on the position. Okay, first argument will be given to, or the first parameter here will be replaced with the first argument, second parameter will be replaced with the second argument, like that. So to this record length. Okay, record length. Then how this will be expanded? So this will be expanded like this. The first line will be the macro call will be used as a command line here, that is dot wr buff 05 comma buffer comma length. That will be used as a command line. That is why it is starting with the dot. Then the body of the macro will be used here after replacing each parameter with the corresponding arguments. So this will become clear x LDT okay, this will be replaced with this REC LTH is replaced with length. So this will become LDT length. LDT length. The next line in the macro definition is LDCH ampersand buff ADR comma x. And this buff ADR is replaced with what is buffer. So LDCH buffer comma x, buffer comma x. The next line is TD equal to x single quote ampersand outdev. Here outdev is replaced with 05. So this will become TD is equal to x dash, this will become 05. Then next line is JEQ star JEQ star minus 3. That is the same. Then WD is equal to x single quote outdev. So here outdev is replaced with 05. So WD is equal to x 05. Then TIXR T JLT star minus 14. Okay, so this part will be this much. Okay, these lines of code will be replaced here. This macro invocation will be replaced with this set of codes. Okay, that is the macro expansion. Then J loop. Similarly, there is another macro invocation. ഇവിടെ macro invocation കൂടി വരുന്നുണ്ട്. അപ്പോൾ ഇവിടെ ആകുമ്പോൾ എന്ത് സംഭവിക്കും? ഇവിടെ വീണ്ടും എക്സ്പാൻഡ് ചെയ്യും. ഇവിടെ എക്സ്പാൻഡ് ചെയ്യുമ്പോൾ എന്താ സംഭവിക്കുന്നത്? ഈ പോർഷൻ മാറും. ഈ പോർഷൻ മാറിയിട്ട് നമുക്ക് എന്ത് വരും? This will be expanded like this. Whenever this expansion takes place, what will happen? Okay, if you are considering this one, then here the lines will be, see, we are using another color. So this 0 5 will be given to outer, then EOF will be given to buff ADDR, 3 will be given to RCO. So the macro call will be like this: 0 5. Okay, this will be 0 5 EOF. So we can use the same color here. EOF comma 3. So the macro invocation is used as just a comment there. Then clear X. This length part is now, what is there? Okay, we can consider the same thing here. Clear X. Okay, that is same. Then next LDT ampersand REC LTH. That part will become LDT. Okay, one thing we can do is we can erase the all code, then rewrite it. That will be better. Okay, so this will be replaced like this: clear X, then LDT ampersand REC LTH. That will be replaced with REC LTH with 3. Okay, so LDT 3. Next is LDCH ampersand buff ADDR. This buff ADR is now replaced with EOF. Okay, so EOF comma X, then next line is TD is equal to X single quote outer. Outer is now this one. Okay, 0 5 itself, 0 5. Then JEQ star minus 3 WD is equal to X outer, same 0 5. Then TIXR T JLT star minus 14. Okay, so this is the replaced code. In this case, these parameters are changed. Here we are using 3 EOF like that. So for each macro invocation, parameters will be substituted with the corresponding arguments, and the body will be replaced here. So this macro invocation will be replaced with this body. Again, the length of the code will increase like that. Okay, so that is about the how a macro will be expanded. Then we have to reconsider our data structures. We have already explained that in our previous class, but I am just refreshing the data structures used in that is used by the macro processor algorithm. So one of the data structure is definition tab or def tab. This def tab is used to store the definition of all the macros defined within this program. So in this example, this is stored rd buff macro. So the entire macro definition will be stored here, but with a simple modification. because these parameters are represented with a positional notation instead of the as such. So ampersand 1 means this is same as indev. Then ampersand here also 1, that is indev. This sorry, not ampersand, this is question mark 2. So question mark 2 is same as this one, buff addr, and question mark 3 is same as record length. So we are using some positional notation. This has some importance, we will explain. Okay. So we have stored the definition corresponding to this macro. So similarly, if there are some other macros, all these macro definitions will be stored in definition table. Then another data structure is name tab. This name tab is used to store the name of the macros defined within this program. So for example, the rdbuff. Then there will be 2 pointers. First pointer will points to the starting point within the definition table, and second pointer will points to the last line within the last line of the definition, macro definition within the definition table. Okay, like this. So corresponding to each of the macro, there will be an entry within the name tab and pointers to the definition tab entry. Then another table or another data structure is argument tab, and this is actually associated with the macro invocation. So while invoking a macro, we will have a set of parameters. For example, here these parameters, these are the this will actually call this as arguments. So these arguments, the argument tab is used to store these arguments. The macro invocation supply in arguments other order store in the argument table. So whenever there is a macro invocation, the arguments within the macro invocation will be stored in the argument tab in that same order. So advantage in ഈ ആർഗ്യുമെൻ്റ് ടാബിലെ വാല്യൂസാണ് നമ്മൾ മാക്രോ എക്സ്പാൻഷൻ്റെ സമയത്ത് ഈ ഡെഫിനിഷനകത്തുള്ള പാരാമീറ്റേഴ്സിനകത്തോട് കൊടുക്കുന്നത്. The parameters within this macro definition will be replaced with the corresponding arguments within the argument table. അപ്പോൾ അതുകൊണ്ടാണ് നമ്മളിവിടെ ഈ ഒരു പൊസിഷണൽ നൊട്ടേഷൻ യൂസ് ചെയ്യുന്നുള്ള അഡ്വാൻറ്റേജ് എന്ന് പറയുന്നത്. പൊസിഷണൽ നൊട്ടേഷൻ യൂസ് ചെയ്യുകയാണെങ്കിൽ എന്ത് ചെയ്യുക, ആ നമ്പർ വെച്ചിട്ട് നമുക്ക് ഈ ആർഗ്യുമെൻറ്റ് ടാബിളിനെ ഇൻഡെക്സ് ചെയ്താൽ മതി. അപ്പോൾ ആ വാല്യൂ ഇവിടെ നമുക്ക് റീപ്ലേസ് ചെയ്യാനൊക്കെ ഈസി ആയിരിക്കും. അപ്പോൾ നമ്മൾ അൽഗോരിതത്തിനകത്ത് പറയുന്നുണ്ട്. ഓക്കെ, so these are the main 3 main data structures used by the macro processor algorithm: name tab, definition table, and argument table. Okay, so next we have to discuss about the detailed algorithm corresponding to macro processor. So the main job of the macro processor is to process the program, assembly language program, or any program that contains macros, and the output of the macro processor will be a source program without macros, that is the expanded program. Okay, so we can simply represent this like so. Okay, so assume that this is our macro preprocessor or macro processor. It is a system software. Input to the macro processor will be program with macros. Output will be expanded program or program without macros, expanded version of the program. So the detailed algorithm we can consider in the next video. Okay. In some cases, a macro definition may contain the definition of other macros. For example, here we are defining a macro macros. The name of the macro is macros, with the macro. Here some typo mistake. This is actually macro. Name of the macro is macros, and this macro contains, the body of the macro contains the definition of other two macros. This is one macro and this is another macro. So there is some recursive macro definition. Okay, this example is actually for some specific purpose. This contains macros. This is for actually for SIC, the RD buff. This contains definition corresponding to SIC for RD buff and WR buff. This specific example contains the definitions RD buff and WR buff written in SIC instructions. Similarly, we have another macro X. This also contains two macros. The body of the macro X contains definition of other macros, RD buff and WR buff. Contains the definition of RD buff and WR buff written in SIC XC instructions. So a program that is to be run on SIC system could invoke macro S, whereas a program to be run on SIC XC can invoke macro X. However, defining macros or macro X does not define RD buff and WR buff. These definitions are processed only when an invocation of macros or macro X is expanded. So while designing our algorithm, we have to consider these cases also, because we have to use we have to design a macro processor, a one-pass macro processor that alternate between macro definition and a macro expansion in a recursive way, is able to handle recursive macro definition. Okay. The definition of macro must appear in the source program before any statements that invoke the macro. This restriction does not create any real inconvenience. So we have to consider these things in our algorithm design. There may be a definition of a macro may contain the definition of other macros in a recursive manner. Okay. So we have to use, or we have to design a one-pass macro processor that alternate between macro definition and a macro expansion in a recursive way. Okay.